So now we come to our today's speakers with the title OPC UA for Mining. I would like to welcome Mr. Jörn Lehmann from VDMA Mining and Mr. Sunny Schone from Inomatics. And now I'd like to hand over to you, Jörn.
Thank you very much, Mark, for the short introduction. Welcome to our presentation for OPC UA Mining. I'm responsible in the VDMA for the standardization and, on the other hand, for the digitalization. So that's our topic for today, OPC UA Mining. And I would like to hand over to Sunny short for introduce himself.
Thank you very much, Jörn. My name is Sunny Schone, and I have the pleasure today to present our activities in OPC UA Mining to you today. I'm a mining engineer from University in Germany, University of Aachen. Since 2 weeks now, a PhD also in the sensor technologies and digitalization for the mining environment. And now I'm here responsible for in the Inomatics for global sales and portfolio development. So we are working in more or less every focus region in mining, in digitalization. And of course, we are highly interested to support the OPC UA Foundation and the OPC Mining with their activities. So it's a pleasure to be here, and thank you, Jörn.
So first of all, I would like to give you a short overview about the agenda of today. We will like to give you a short introduction into mining by Sunny, and then we gave a short, brief overview about our use cases, the reason for standardization in our field of mining, and we come up with the information on our activities on conveying and processing and the upcoming cooperation with Brazil and Senai with the VDMA on our activities in processing.
Yes, thank you again, Jörn. Let's talk a little bit about mining. I think most of you, of course, are really familiar with mining, but we want to give you a small overview to show how the complexity is growing in mining over the last years and, of course, also in the future. When we're looking into this small sketch here, we see that we have open pit mines, underground mines, we have really deep underground mines or really high open pit mines. We have specific or really special extreme mining like deep sea water mining. And of course, a huge amount of different concepts, how to mine, how to process the material, what is the support of electrical power or power support itself, what are safety environment, communication modules, how the mine is working, is it blasting cycle or is it cutting procedure, which material is mined, this defines more or less in which environment we are working there. So we see, or what we want to show here is in the end that the mining environment is far away from simple. It's more or less the other way around. It's highly complex, and a lot of different influence factors are more or less defining how we work in the mining environment and what are our limitations. And of course, we see in the future, also in the mining, like in other industries, huge changes in the future. Of course, we wanna talk about autonomous mining, remote controlled mining. We want to use more the IT sector or digitalization aspect possibilities in the future. So use data for optimizing, for higher safety environments, or more or less use digitalization not only in a higher performance mining in the future, also for example, realized mines in really remote areas or in areas we are not able to send humans anymore in the future to more or less mine our products or our materials for the future in our industry in the end. So when we look at this slide, and I think it's really clear that when we want to go in this direction to use digitalization in the future, we have the complexity of a lot of different machinery, a lot of different vendors who are working together, a lot of different material value chain steps which are more or less integratable. And especially this we can reach with the digitalization in the future. And therefore, of course, the complexity is decreasing if we use standards in the digitalization usage and in the communication between the different machines and the different material value chain steps, and of course the different aspects of such a complex mining environment. And this is also something what we saw or what we heard in several focus regions in the world when we talk about mining, that especially the end customers are always talking about, okay, with digitalization now we have a tool to cover the complete operation, not only look into one single aspect, so to cover the complete material value chain, all the machinery, all the different aspects, all the interfaces. But therefore, of course, we need high secure and high performant communication. We need standardized data modeling. We need standardized user interfaces or interfaces between different aspects of the IT infrastructure. And this more or less leads to the point that we started really intensive discussions in the VDMA in Germany to bring all the different stakeholders together to define, okay, if we want to be better in the future, if we want to help our end customers in their mining environment, in their mining business, it would help a lot if we have a standardized IT infrastructure, protocols, and usage of data. And with this initiative starting, we decided to more or less, in comparison to the mine or linked to the mining environment, which is how it's realized in the reality, we are dividing our activities in different groups. And maybe you go now to the next slide, Jörn.
Sure.
And when we look into the material value chain, we see here the same aspects in our groupings in the end. So we decided, okay, let's narrow down a little bit the complexity again to say, okay, each and every material value chain step. So the open pit or the underground mining itself in drilling and blasting or in continuous mining. And then of course we have this transport aspect of conveying, or the combination of discontinuous transport and continuous transport. And then of course a lot of other aspects like the processing afterwards or the underlying different aspects. And let's group our initiative in the different material value chain steps and start here really the discussion to say, okay, what is our requirements from the end customer market to us as standardization segment, or how we can standardize here IT infrastructure, especially communication protocols, to more or less face the problems from the industry. And now I would like to hand over again to Jörn, because now you can want to give you a deeper insights in our work in the different groups, in the different aspects.
Thank you, Sonny. Yeah, that's mining landscape. What we see was the starting point to establish our working groups. And we try to form the special, or we call it specialist groups. For example, for longwall mining, for load and shovel, or for the conveyors, and for the drilling and blasting. And this lead us to our joint working group and the organization form that we have established, because we have no one single or important machine in mining, so we could start with them. Our starting point was the interests of our members to join in a specialist group and to create the first steps or the first companion specification for the special interests. For example, in longwall, in mobile machines, or iReaders, that's a international rock excavation data exchange standard. This standard is already established in the mining community, and we didn't want to redevelop things a second time. So we tried to get these initiatives integrated in our working groups, so everyone have the possibility that the mining companion specification will meet all the requirements from the different stakeholders, from the mine operators, from the automation guys, from the integrators, as well from the manufacturer of the mining equipment as well. And as you see, we have different members in the different specialist group. For example, in Longwall, it was a very small group, but this group was before very active in automation. Longwall is a really high automated system, but at the end, they try to decide how we can use OPC UA to get more information, communicate easily between the different machines and to the subordinate systems as well. As you see, we have members, different members in conveying, in mobile machines, and we were supported by the Institute of the RETH Aachen, the AMT. They give us support in the drafting and developing of the companion specification. Now it's sent over to my colleagues of the VDMA, which now will support us in writing and editing the companion specification in the future. And I will point it out that we now have a new working group in processing in cooperation with SENAI, a institute for education in Brazil, with strongly connection to mine operators. And I will come back to this at the end of our presentation. So let's come up to a second time to the mining landscape or image, and let's show you what we have already done with our mobile machinery. We have use cases developed in loading, unloading, positioning, and queuing for mobile machines. We have the Longwall with the, for example, Shearer Advanced. That's it. For example, or the horizontal control for a seam in the coal mine. And with our working group on IRIDIS with a drill rig mapping. And we have ongoing activities on the side of our working group on conveying and processing with, for example, condition monitoring or screen overload. In total, we have developed at the moment 21 companion specifications with our specialist group here in mining. What is the idea behind the architecture of our companion specification? We would like to capture all the communication aspects in the mine, in the vertical as well as in the horizontal aspects. That's our view of our assets and system that we want to integrate in our companion specification, coming on top with the planning and logistics services, operation and execution service to the monitoring and supervision services. And in the bottom, we have all the extraction equipment, the loading equipment, or transport and dumping equipment. So we try to integrate the whole mine with our OPC UA companion specification. The idea behind is also to give the mine operators at the end an easily understandable companion specification, so they really have no difficulties to implement parts of our mining companion specification instead of forced to integrate the whole companion specification of the whole mining. We think, and that's our idea, how we manage all this and develop it in a manner that mine operators can take a look on our companion specification and decide for their process, trying to get these information models or companion specification integrated that they are needed and not the whole mining companion specification in the total. So how looks our structure of the documents? We have on top the mining general document, which is more or less the information and introduction and explanation how to read our mining companion specification. Then we have a part for the application and use cases. So everyone can take a look what kind of use cases are developed in our companion specification and have a short overview if it's usable for their special mine operation, for example. And then we have the upper parts for the systems like external standards or the planning and logistic and operation execution systems, the monitoring system, and then we have all the stuff for the machinery and equipment that is now divided in extraction, loading, transport, mineral processing, and support equipment. And here you can see we have some of these systems already developed, like the rock crusher, the armored face conveyor, or the rear dump truck, for example. So the documents are available, and for us, it's more important to give you the possibility to get these documents used in your environment, so you can get or you can receive the documents via the VDMA internet website or about the OPC Foundation with the note sets. And for example, the easiest way is if you go there and search for the numbering or to give the input or the search word for mining, and then you can receive all the mining standards which is already developed in the future, developed by now. So that was a short overview about our work that has been done. And now I'm coming to our ongoing work with our conveying and processing. We start this topic with conveying and processing in one specialist group. You see in both of these images, you see a conveyor, but at the end, the groups decided to divide it in two parts, in the conveying part and on a processing part, to be sure to develop the requirements for each specialist group in a manner that it will be not getting too complex. So you think maybe a conveyor is a easy and simple part. Let give me you an overview about a conveying system. It's more or less a system with different types of devices and machineries, like a winch, a drive, the belt, the idlers, the belt scale, the frame, and we have the belt cleaner as well. And then these conveyor is also integrated in upstream systems, for example, trucks, which are for the loading, or a crusher, and for the upstream, other conveyors, or they give it the material to a crusher, a grinder, a mile, or a silo or bunker. And most of the bigger conveyors have communication with superordinate system like SCADA system or a weather station. And in the future, most of the companies are thinking about a digital twin.
Maybe in addition, we can come back a little bit here to the point, what is our goal here? When we're looking at such a system and we see that we have here a lot more or less a multi-vendor system with different companies working together to create such a conveyor belt, or more or less to create such a complete system. And when we now look into, of course, the trucks who has to communicate with the SCADA system from a conveyor belt, there could be 3 different types of trucks from different companies in the end. When you want to exchange some components of your conveyor, you have different vendors, you have different parts of technology you can implement. If you want to do an extension of your conveyor belt, for example, retrofit a belt scale or retrofit one of these components, then of course directly you can come into trouble to implement this new system into this complex environment in the end. And therefore, I think this is the biggest aspect what we want to reach here with our conveying processing group. With a standardization in implementing such technologies into the environment of a conveyor belt, we can be faster and safer if we have a high standardized protocol what we can use in the end. So if the introduction is so clear that every vendor is more or less keeping this or following this standardization, then it's more like a click in and click out process. But on the other side, what we often see in the market, when we now want to change or retrofit a new technology into this complex environment, then there's a lot of work required to come to a running or more or less an optimized running point of the conveyor belt. And therefore, this is, again, I think it's a good example to show what OPC UA as standardization communication protocol implementation, and especially the work we are doing here with the companion specifications is helping a lot for plant lifecycle management and execution of different projects. Thank you, Jörn.
Thank you, Sunny. And yeah, as Sunny mentioned, in our working group, we have different types of companies. For example, Arthur Küpper is a manufacturer for idler. Becker Mining, a integrator and control system manufacturer. Innomotics, Sunny, I think you can explain better than I what you are.
Yeah, in the end, this, for example, is a good segment. Innomotics is former known as LDA from the Siemens AG. We are supplying electrical components, motors and drives, and automatization systems for all the different aspects of machinery in the mining environment. But this is exactly the case what I mentioned before. And this is the beauty of our VDMA initiative under the lead of Jörn, because we are bringing here OEMs, technical suppliers, end customers, high-end technology providers together in one group and open discuss, okay, how could we work in a based and high professional way together into the future to really come to a digital mine for our end customers in the mining market. And then we are more or less, clearing a little bit the borders of proprietary systems, which is avoiding having this flexibility. But as we think, or we believe in it, and even our group members believing in it, that only if we can and if we work together into the future, we can reach really a high-end digital mine or mining of the future in the end.
So, and we have developed in this working group several use cases, and we have to prioritize them. And we have prioritized these 6 use cases for the first release that we would like to release in April 2025 for the bauma 25, and show them all the visitors of the trade fair. And maybe I pick up only 2 of them. The startup procedure is a use case for the regular startup of a conveyor belt, so that the conveyor belt starts gently as possible in order to avoid unfavorable dynamics of the belt tension, and not to give too high belt forces or too low belt forces that lead to damages or to loss of the material that's on the belt itself. And the second use case would be, for example, load sharing. That's in the normal procedure, in the normal operation, in the stationary operation. If you have several motors, if you are talking about a long conveyor belt, about kilometers and kilometers at the end, so that the forces of the different and the required speed and mass flow and the power of the local drives are not adjusted in a manner so that the conveyor belt is running smoothly, depending on the mass flow of the material that the conveyor belt should be transport. Then we have the priority 2. These priorities are the lower points or the use cases that are not the essential processes of a conveyor belt, like the conveyor KPI or the pulley utilization time. These are information that's for the customer from interesting, but he can't calculate them. And it's depending on the knowing about the load, the speed, the cleanliness level of the belt, and the state of the belt. For example, And for this calculation, the use case needs, for example, the data from the belt speed, the mass flow rate from the belt scale, the cleanliness level from the belt cleaner system, the belt wear rate, and the bearing temperatures from the pulley, and the belt tensile force from the tension station, for example. So you can see, as Sunny told, you think it's a simple system, but at the end you need very much information to get more information for the customer, and these information should be shared between different manufacturers. At the end, in a superordinate system, for example. And now we come to our specialist group on processing, and it's the same as in conveying. We have different manufacturers with different knowledge between giving manufacturing different types of processing systems, like VIA Minerals, a HGPR, or Steinert GmbH. They provide sorter in different types, or Kleemann for mobile equipment in the processing industry, and so on. And so we formed this group, or this group was formed by themselves, because they are interested to get the communication between their different types of machinery and to give the mine operators better information about the process and about the condition of their machines at the end. Because in mining we have no full liners at the end, so we need the information between the, as Sunny told us, that most we need standard for the communication of the different machines, so so that the mine operator have at the end a benefit on this communication and automation and digitalization of the mine process. The ongoing work in processing is they are not so. The ongoing work is just in the first step for developing the use cases. They're now defining the data of the communication between the different machines and systems, and they check existing companion specification for the usable concept that they like to use. For example, for the energy consumption for a machine, for the process, or the condition monitoring, or the job monitor, or the counter for the process and the time. So then let's come to the last slide at the end. For the cooperation with Brazil, we are establishing a specialist group with VDMA and Senai, with manufacturers and mine operators. And it was a big effort for our bureau in Brazil that they get these different stakeholders together. In our first meeting, we have 49 persons from the mine operators like Vale and Anglo America, and all the VDMA members. And the second meeting was about 30 participants, where we decided to start the process now actively. They are working in Belo Horizonte by the lead of Senai in the first working group, trying to develop the first use cases together with the mine operators, to have more and more involvement of the mine operators, so that we all together gain more insights in the requirements of the mines to establish and develop companion specification with the requirements from the mines as well. Maybe a short question to Sunny. Would you like to add something? You're muted, unfortunately.
Sorry, my mistake. The key aspect here is, and this is something what we also want to highlight, that the things what we are doing in the VDMA mining group or in the OPC UA Foundation is nothing what is only related to one area on the world. I think mining, especially the future way of mining, is a global thing. It's more or less an over-regional topic where different international companies are working together. And also the partnership here between Brazil and Germany is highly important to really face the requirements and the challenges from the end customer market. So highly welcome to form such groups, work together, be more efficient in the end, so that we can really form the mining operations of the future together. So I think it's a key aspect of our work, and hopefully in the future we have more of these cooperations.
Yeah, and we are inviting all these stakeholders in the mine worldwide to work with us together. We have now meetings scheduled in September and October in Brazil. And maybe in September, for example, we are at the Exposipram in Belo Horizonte. So you're invited maybe to come there. And if you want to meet us here in Germany, you're welcome to work with us together on our aspects in mining, and to give more and more aspects in our companion specification, so that we develop step by step the companion specification for the whole mining industry.